Hey guys, Ms. Zarnowski here. I'm going to walk you through how to do the practice test for Module 7. Just a reminder that your test is tomorrow, so please make sure that you are finishing and correcting your practice test. If you do have any questions, I will be here after school today, and I will be here before school tomorrow. So feel free to stop in and see me in person or send me an email if you have any questions. Okay? So let's go ahead and get started. Question number 1. It says simplify and add the like terms. So we have square root of 24 plus square root of 54 plus square root of 96. So hopefully you recognize that 24, 54, and 96 are not perfect squares. So what that means is we need to find a factor of each of those numbers that is a perfect square. So for 24, the factor that is a perfect square is 4. And in order to get 24, you multiply by 6. With 54, the factor that's a perfect square is 9, and you have to multiply that by 6 to get the 54. And with 96, the factor that's a perfect square is 16, and hopefully you've noticed the pattern. Yes, you have to multiply that by 6 to get the 96. Now the reason we're happy is because we have a 6 underneath each of those radicals. So that means when I pull out the square roots of the perfect squares, I'm going to have the same thing underneath the radical. So the square root of 4 is 2. So the 2 comes out front, and I'm left with square root of 6. Square root of 9 is 3, so the 3 comes out front, and I'm left with square root of 6. And the square root of 16 is 4, so the 4 comes out front, and then I'm left with square root of 6. So remember, we talked about how the only time you can combine radicals is if the stuff underneath the radical is the same. That's what makes them like terms. Well, in this case, we do have the same thing under all the radicals, a 6. So we can combine them by adding the coefficients. So 2 plus 3 is 5, plus 4 is 9, root 6. And that's the answer to number 1. Okay, number 2 asks us to simplify the cubic root of 81, x to the 13th, y to the 9th, and z to the 14th. So again, looking at all of those numbers, hopefully you recognize that they are not all perfect cubes. In fact, 81 is not a perfect cube. So we are going to rewrite this cubic root using factors of these terms that are. So using your orange perfect power sheet, hopefully you found a factor of 81 that is a perfect cube, and it happens to be 27. So we can break 81 up as 27 times 3, because that's how you get the 81. X to the 13th, well, that's not a perfect cube either. 3 does not go into 13 evenly. So we need to break that up. The largest factor of x to the 13th that is a perfect cube is 12, and that leaves us with 1x left over. Y to the 9th is a perfect cube, because 3 goes into 9 evenly. And then again, z to the 14th isn't. So the largest factor of z to the 14th that is z to the 12th, and that leaves us with z squared left over. So now I'm going to take the perfect cubes. So the cubic root of 27, notice I'm going to cross it out when I pull out, is 3. I cannot take the cubic root of 3, it's too small. 3 goes into 12 4 times, so I can pull out x to the 4th. X, there's not enough left there, so it's going to stay. 3 goes into 9 3 times, so I take out y cubed. 3 goes into 12 4 times, so I take out z to the 4th. And 3 does not go into 2. There's not enough left there. So with the stuff that's left, I need to multiply by the cubic root of 3x z squared. And that's it. That's number 2. Question number 3 combines the principles of question number 1 and question number 2, where we've got to simplify the stuff under the radical, and then hopefully we have like terms that we can add together. So I'm going to simplify each term separately. When I look at the first square root, I notice that 45 is not a perfect square. However, there is a factor of 45 that is 9. You have to multiply it by 5. Y squared is a perfect square, so I'm going to leave it written like that, and I'll come back and take the square roots in a minute. 20 is also not a perfect square, but 4 is, and that's a factor of 20. And 180 is not a perfect square. However, we do have a factor of 180 that is a perfect square, and that would be 9. Well, actually, I think we can go bigger. 16 doesn't work. Maybe let's try 36. 36 works. Perfect. Hopefully something times 5, right? Since we have a 9 times 5 and a 4 times 5. So we have 5x square root of 36 times 5 y squared. So now I'm going to pull out the perfect squares. So in the first term, we have square root of 9. That's a 3. When that comes out, it gets multiplied by what's already there. 5 is going to have to stay. Y squared is also a perfect square. Square root of y squared is y. So we're going to take a y out. So that makes our term, our first term here now. 3 times 2 is 6, xy square root of 5. Okay? Second term, square root of 4 is 2. That comes out. Also can take out a y. 2 times 3 is 6, xy square root of 5. Square root of 36 is 6. That gets multiplied. Take out a y. 6 times 5 is 30, xy square root of 5. So notice that all of our coefficients are xy's, and all of our radicals are square roots of 5. So I can combine my coefficients. 6 plus 6 is 12, plus 30 is 42, xy square root of 5. You don't change the x and y. When you add like terms, you just add the coefficients. And that's number 3. Okay. Question number 4 asks for domain and range. It does not specify if you need inequality format or interval format, so either will work, and I will show you either. So just a quick recap. When you're looking at domain, you're looking left to right. So when I look left and right, my domain for my x values is anything to the right of -1. So that means my x values need to be greater than or equal to -1. To write that in interval notation, start with your farthest left bound. My farthest left x value is -1, and since we can include it, we use brackets. My farthest right bound, since my graph has this arrow on the end, that means it's going to go to infinity all the way to the right. So I don't have a bound. And since we can never actually get to infinity, we're going to use a parenthesis. Because remember, brackets are inclusive, meaning you use that number. Parentheses are exclusive, meaning you never actually get that number. And always remember, parentheses go with infinity because they're both curved. Okay? Range, you look up and down, but you always look from the bottom down to the top. So the lowest point on our graph, notice, is 0. And then all of our y values are above there. So that means our y values have to be greater than or equal to 0. Or, writing this in interval notation, our bottommost bound, the lowest point on our graph, is 0. And it actually hits 0, so inclusive. And our uppermost bound, well, it's going to continue up to infinity. And since you can't reach it, again, use a parenthesis. Okay? So either inequality format or interval format. You don't have to have both. Okay? All right. Number 5 is a cubic root graph. Domain and range for a cubic graph, very easy. So again, for domain, looking left to right, you should notice that there are no numbers that are excluded. So that means our domain consists of all real numbers. Or if you want to write this as an interval notation, Your left bound goes all the way to negative infinity. Your right bound goes all the way to positive infinity. Okay? For your range, you look bottom to top. Hopefully, again, you'll notice that this graph has arrows, so it's going to go up to the left to infinity and down to the right to infinity. So that means there's no y values that are excluded either. So all real numbers or negative infinity to positive infinity. That's the nice part about cubic root or any odd root functions. It's always all real numbers or negative infinity to positive infinity for the domain and the range. Okay. All right, number 6 gives us two functions. F of x is 2x cubed plus 6, and g of x is 3x to the 5th. And it wants us to compose them. So f of g of x. So remember, that means you take the innermost function and put it into the variable for the outer function. So we're going to be taking the g of x function and putting it in for x in the f of x function. So when I do that, that's going to give me 2 times something cubed plus 6. And that something is the g of x function. So I'm going to put my 3x to the 5th in there. Okay, so we got a lot of work to do to simplify the start of this one. First of all, order of operations says that we have to take care of exponents before multiplying. So that means this third power needs to get applied to both things inside my parentheses first. So I get 2 times 3 to the third power is 27. X to the 5th to the third power to a power means multiply, so you get x to the 15th. Okay? Now I do my multiplication. 2 times 27 is 54. X to the 15th plus 6. And of course, those are not like terms, so they cannot be combined. That's it. Function composition. Number 7 says, what is the equation for the inverse of the function f of x equals 4x plus 9? Well, remember, inverse means switch x and y. So it might help to actually have a y. I'm going to just replace f of x with y. So now then, I can switch them. So I'll have x equals 4y plus 9. And now I need to rearrange just to get the y by itself. So we're back in slope-intercept form. So I'm going to subtract 9 from both sides. X minus 9 equals 4y. I'm going to divide both sides by 4. So y is x minus 9 divided by 4. And now that y is by itself, I'm going to put it back into function notation. And since it's an inverse, I'm going to write it as f inverse of x equals x minus 9 divided by 4. Or you can split up that denominator so that you're in slope-intercept form, and you would have 1/4 x minus 9/4. Okay? Either of those two answers will work. All right, number 8. You saw something similar to this on your skills check yesterday. Which equation matches the given graph? So, first thing I would look at is the fact that, hey, this is a cubic root graph. Some sort of cubic root of x. So what I'm going to do is I'm going to eliminate any of the options that aren't a cubic root graph. So for example, A, that's a square root. Not going to work. Same thing with D. That's a square root. Not going to work. The next thing I notice is that it is decreasing. So that means from left to right, we are going down. So that means that this is a negative graph. So we should have a negative in the front. So B would work, C would work. D does not work because it's missing that negative sign. It's positive. Okay? And then the last thing now I'm going to look at is the difference between them is one's a plus and one's a minus 1. So I'm looking at where I shifted. This graph has shifted 1 to the left. Well, remember, your horizontal shift is always opposite. So that really means x plus 1. So the graph I'm looking for, or the equation I'm looking for, to match this graph is B, because this means left 1. This means right 1, and that's not what we want. So the answer for number 8 is B. All right, question number 9. It says the velocity of a free-falling object is given by, and I'm going to underline some important information here. V equals the square root of 2gh, where v is the velocity, g is acceleration due to gravity, and h is the distance in feet the object has fallen. On Earth, g is 32 feet per second squared. That's kind of important. It says if an object hits the surface with a velocity of 56 feet per second, from what height was it dropped? So I'm going to start, like you should always do, write down that equation they give us. V equals square root of 2gh. And let's plug in the information we do know. We do know that velocity, that's v, is 56. And we do know that g on Earth is 32. So 2 times 32, h. And we're solving for h now. So I'm going to do some simplifying here. 2 times 32 is 64. Now notice how the 64 is trapped under a radical. So we got to get rid of that square root. And the best way to get rid of a square root is to square. Square root and square cancel each other out. So we have 56 squared, which is 3136, equals 64h. Divide by 64, and you get that h is 49. So 49 feet. And that's your answer. All right, question number 10 says, what is the new equation of the graph of g of x equals the square root of x when it is shifted 7 units left, 4 units up, and a reflected vertical stretch of 3? So we have a square root function, g of x equals square root of x, and we have a number of transformations happening. So the first thing I want to talk about is this shift 7 units left. That's your horizontal shift. And remember, your horizontal shift deals with the x-axis, moving left and right, so that gets attached to the x. And since it's under the radical, it's always opposite. So 7 units left is actually going to be x plus 7. Okay? The next shift we see is a 4 units up. That's a vertical transformation. Vertical transformation gets added on at the end, and it's true. So since it's a 4 units up, we're going to add 4 to the end, plus 4. Down would be a minus. And then our last transformation here says a reflected vertical stretch of 3. And that's what comes in front of the radical. The fact that it's reflected tells us it needs to become negative, and the stretch is 3. So there's our equation. G of x equals negative 3 times the square root of x plus 7 plus 4. Question number 11 is a little bit tricky. We haven't seen an example like this before, so we have to put together everything that we've been learning about in this unit to solve this problem. It's talking about inverses. We're given the graph of a cube, so we know we're looking at some roots here. It's really everything that we've seen all put together. So the first thing I would like you to look at is the graph. Hopefully you recognize this to be the graph of a cube function. This is an x to the third function. Okay? Now, of course, it's been transformed, so we don't know if there's any kind of coefficient or plus or minus, but we know that this is a cubed function. Since we're looking for the inverse of a cube is a cubic root. So our equation, if it's the inverse, should be some sort of cubic root, which A fits, B fits, and C fits, but D and E do not. Those are still cube functions, and that's not the inverse. Okay? The next thing I know then is that I'm given some points on this graph. So what I'm going to do is I'm going to pick one of the points off the graph. So we have the point 0, 1, let's say. 0, 1 is on this graph. Well, we know for an inverse, you switch the x and the y. So that means in our equation, we should see the point 1, 0. So what we can do is we can test 1 for x in each of these equations and see which one of them gives us 0 for y. And that must be the equation of our inverse then. So let's start with A. If I put 1 in for x, I get 1 minus 1, which is 0, times 3 is 0, and the cubic root of 0 is 0. And that gave me exactly what I needed. So that is probably an option. That is an option. It's probably our answer. But let's test the other two. If we put 1 in for x here, one plus 1 is 2, times 1/3 is 2/3. The cubic root of 2/3 is not equal to 0. So that cannot be my answer. And the last one I'm going to look at, option C, y equals 3 cubic root of 3 times 1 plus 1. Well, again, 1 plus 1 is 2, times that 3 is 6, cubic root of 6, again, not equal to 0, so it can't be C either. So the answer here is A, and that's really the best way to try and figure that one out. Okay, since we haven't seen this one before, if you have questions, please come see me after school or before school tomorrow, and maybe we'll even talk for a couple seconds before the test on Friday about this question. All right, number 12 says, what is or are the solutions of this equation? This is what we did in class yesterday. We need to get the x's out from underneath the radicals. So the best way to get rid of a radical is to square. So we're going to square both sides. So on my left, when I square a square root, they cancel each other out. So I get x minus 3. On the right, I am squaring a binomial. When you square a binomial, that means you have to write it twice. So x plus 4, square root of x plus 4, minus 1, times square root of x plus 4, minus 1. Okay, so I have x minus 3 equals, I'm actually going to go ahead and FOIL this out. Square root of x plus 4 times square root of x plus 4 is just x plus 4. Square root of x plus 4 minus 1 is negative 1. Square root of x plus 4. Negative 1 times square root of x plus 4 is negative 1. Square root of x plus 4. And negative 1 times negative 1 is plus 1. So we've eliminated one of our radicals. Seems we've created two new ones, though. However, we do have some like terms. This 4 can be combined with this plus 1. And our two radicals, since the stuff underneath them are the same, those can be combined. So we get x minus 3 equals x plus 4 and plus 1 is plus 5. Minus 1 and minus 1 is negative 2 square root of x plus 4. So now we've got only one radical, and we got to get rid of it. And the only way to get rid of it is to start by isolating it. So that means we need to subtract this x over to the left and subtract this 5 over to the left. And when I do that, I get negative 8 equals negative 2 times the square root of x plus 4. Alright, well, divide off that negative 2 again to continue isolating the radical. And I get a positive 4 equals the square root of x plus 4. So I got to get that x out from under the radical. Best way to get rid of that radical, square it. Square one side, you got to square the other. So you get 16 equals, square root and square cancel each other out, so x plus 4. Subtract 4. X is 12. And the beautiful thing about this problem is that you only got one solution, which means you do not have to check for an extraneous solution. Please be advised that tomorrow, if you somehow end up with a quadratic and you have to factor it, you'll probably get two solutions, one of which may be extraneous, so you might have to check it. Okay? But in this case, we did not end up with an extraneous. All right, number 13 says, what is the solution to 6x cubed plus 75 equals negative 309? We need to start the same way here, where we need to isolate that term with the x. So I got to get rid of this 75, and I'm going to subtract that off of both sides. So I get 6x cubed equals negative 384. Okay? Next up, divide off your 6. And you get x cubed equals, I'm going to need my calculator on this one, negative 384 divided by 6 is negative 64. And then, again, to get rid of the third power, we've got two options. We can either take the cubic root, which a cubic root and a cube cancel each other out, and then use your orange perfect power sheet. The cubic root of a negative 64 is negative 4. Or, when you're at the point that it's x cubed equals negative 64, remember you can get rid of a third power by raising it to its reciprocal, the 1/3 power. Because 3 times 1/3 is 1, and x to the first is just x. And now you can plug that in your calculator. Make sure you put parentheses around the negative 64, and you will get negative 4. So either or. Okay? All right, number 14. It says, Christian is shopping at Best Buy for a laptop for college. The one he wants to buy is $799.99. The store has it for 15% off this weekend, and his parents give him a $150 gift card for his graduation that he can use. Which discount should be applied first to give Christian a better deal? What is the lowest final price? So hopefully you remember doing this problem. This is a justification type problem, so we do need to show all of our work. And so what we're trying to do is we're trying to figure out, would it be better to take the 15% off first and then the $150 gift card? Or would it be better to take the $150 gift card off first and then the 15%? Now, I'm sure you remember our class discussions on this, and we came up to the conclusion that it's always better to take the discount off first. However, you still have to show both directions. So, if we want to start by taking 15% off first, we have our total $799.99. Instead of multiplying it by 15%, because that's what we're taking off, I'm going to multiply it by what we're actually paying for. So out of 100%, if you take off 15, that means you're paying for 85% of the product. So I'm going to multiply it by 0.85, because that's 85%. And when I do that, it brings the price down to $799.99 times 0.85. Brings the price down to $679.99. Then we have to subtract off our $150 gift card. And that brings our price down to a grand total of $529.99. Not bad for a new laptop. Okay? Let's check the other way around. Here we're starting by taking off the $150 gift card. So $799.99 minus $150 brings your total down to $649.99. Now again, if we're taking the 15% off here, that really means we're paying for 85% of this total. So I'm going to multiply that by 0.85. And doing it this way brings you down to a grand total of $552.49. So let's compare it to final prices. It's clear that $529.99 is cheaper, but because this is a constructed response question, you have to answer all the questions. So the first question says, which discount should be applied first? So you need to answer that 15% should be taken off first. Lowest final price is $529.99. Okay, that's the answer to the question. All right, our very last question on the practice test, number 15, asks us to graph the function. It says then state the domain and the range. So let's start by graphing it. The first thing I'm going to look at is the fact that, hey, this is a cubic root function. And I know that the parent function for a cubic root looks like this. However, our graph is being transformed. So the 2 out front tells me that this thing, the fact that it's positive means it's going to increase. The fact that it's a 2 tells me it's going to be stretched. And I'm shifting 3 right, 1 up. Because remember, the first shift is the opposite. So my turning point is going to now be at the point 3, 1. Now, at this point, I'm fine with just a sketch of the rest of the function. Some of you might want to put it in your graphing calculator to get a couple extra points. So I'm going to quickly review with you how to do that. So, open up your graphing calculator, and this might take me a second here because I didn't have it ready to go. And once you have it opened, you're going to go to the y equals button to enter in your function. Okay, anytime now. All right, so your calculator probably looks like this. Turn it on, push y equals. Make sure you clear out any functions that are already in there. And now we're going to enter it. So 2, cubic root button is found by pushing math, and then cubic root is the 4th option, of x minus 2, move out of the radical, or close the parenthesis, plus 1. When you do that, you can see the graph start to come up. It's been shifted right 2, up 1, and it's a little bit stretched, and it's still positive, so increasing. So to get some other values, you can push second table, which is the graph button. And let's find some nice pretty points. So I'm seeing -6, -3, 1, -1. I'm going to get those down before I forget them. -6, -3. Oops, wrong thing. -3. 1, -1. Back to my calculator. 1, 3, or 3, 3. 2, 1. And that looks like it should be enough. So 2, 1, 3, 3. So I'm going to go ahead and finish off this graph. To match the cubic function. Now it asks me to find the domain and the range. So remember, we already did a domain and range style question. And when we did that, we talked about how nice it was for the cubic root function because it pretty much is always all real numbers. So looking left to right for our domain, we have all real numbers, and we also know that the left bound is negative infinity and the right bound is positive infinity. Same thing for range, all real numbers, and when you look to the bottom, you go to negative infinity, and to the top is positive infinity. So you can really write it as all real numbers or interval notation. You don't have to have both of those. Okay. Hopefully this helped. If you have any other questions, remember, you can come in see me after school today or before school tomorrow, or if you have class after lunch, you can come in during lunch. Okay? Or send me an email.